Hi there, in this video I'm going to machine the cylinder block for the odds and ends engine. Now the cylinder block should be made out of a piece of mild steel, but I'm going to use aluminium, and it'll sit on there like that. It'll be bored out to take the cylinder sleeve like that. Well, this is a side view of the cylinder block, and the idea is that it'll be bored out here to take the cylinder sleeve, and it would be bored out here to take the water. And you can see here that this area is also machined out to create like a water jacket around the cylinder. So the water will be fed in here and it'll surround the cylinder sleeve to keep it cool. Now this design isn't fantastic because this area here has got to be machined so accurately to enable the sleeve to be press fitted into it and create an airtight seal. If I don't get an airtight seal around here, then this engine's going to lose compression and it'll be no good. But unfortunately, if once I've pressed this in and I don't get an airtight seal, I don't think there's any way I'm going to be able to get it out again. So what I'm going to do is, I think I'll use something like JB Weld just prior to press fitting it. So I'll put some JB Weld around here and then press it in. Now if that doesn't work and I find that I have lost compression, it might be that I need to modify this design. I think others have, where they must machine this out somehow and create a cylinder head. But hopefully I won't have to go down that route. So I think my first challenge will be to bore out the hole for the cylinder sleeve. Now looking at the ISO system of limits and fits, I think this area here where it initially pushes through, I think I want something called locational transition for accurate location. And doing the maths, well, it's a K7/H6 I think, and working it out, I think the maximum interference is 7/10 of a thou. So this diameter here needs to be no more than 7/10 of a thou less than the cylinder sleeve. So the cylinder sleeve is 1.2347, so this diameter here needs to be around about 1.234, no smaller than that. Now on this end here I need a location interference, I think P7/H6, so that's the maximum interference there is 0.0016 of an inch, and that makes that diameter to be 1.233, so a tighter fit, which obviously makes sense. So I'll go over to the lathe and set this up in the 4-jaw chuck, and then we can see how we get on. Well, this is going to take a while, so I'll get back to you once I've opened it up a bit more. Well, I'm getting there gradually. I've put this larger boring bar on now. I'm going to a depth of 1 3/4 inches. Okay, so I've just put a new tip on the boring bar and done a fine feed, and we're getting close. Okay, so the target is 1.2330 and this comes in at 1.2135. So the difference is 0.0195. So I need to take off just over 9 thou on this edge here, but I'll do that off camera. Okay, so I've just made a cut of about 1/2 inch in there, and I measured it, and it comes in at spot on 1.233, which is what I'm aiming for. So using the fine feed, I'll cut the whole length. Once I've done that, I'll then take another thou off this diameter for half the length of the bore. Well, this now measures spot on 1.233, and that should be a really good interference fit, I reckon, once it's pressed in. So what I'll do on this half here, I'll just open it up by 1/2 thou, just to make it a little bit easier when pressing in. The important bit is the far end. That needs to be absolutely airtight. Okay, so now I need to machine out this water jacket area. So I'm going to use this tool. Well, this seems to be working. Well, that looks okay. Now the instructions suggest fitting the cylinder sleeve before milling this section out here. I'm going to do it the other way around. I'm going to mill that out and then I'll fit the sleeve later on. Okay, so first of all I'm going to mill out the corners with this slot drill, and I'll go to a depth of around about 1 inch. Well, slight change of plan. I've gone down to a depth of 3/4 inch at the moment because the length of this slot drill isn't long enough. Well, when I milled out the body for the farm boy, I did it on my mini mill, and it was quite sort of difficult really. But on this big mill, it's just a piece of cake. Very easy going. I think in one of my previous videos when I was doing something similar on here, I was using the fine feed knob, and somebody commented, why using that? You should be using the normal handle like that. And yeah, it makes life a lot easier. Anyway, I'll carry on going round and till I've milled it all out to a depth of 3/4 of an inch, and then I'll have to find a longer slot drill and drill to just over an inch in depth in total. And I'll do all that off camera. Well, that seems to have worked out okay. It's currently 3/4 of an inch deep, and I need to go down another 1/3 of an inch, but I think I can probably do it now with this slot drill, now that a lot of the material's been removed. So I'll give it a try. Well, that seems to be working okay, so I'll complete the rest of the milling off camera. Well, that seemed to turn out okay, so what I need to do now is, with this slot drill, is to open up a section into the water jacket area. I think I've got my maths right. So I'll continue opening up that area and then I'll get back to you. Well, so far so good. And I drilled and tapped a hole for the spark plug. And now there's a requirement to make a sort of circular undercut here. So I think I'm going to have to make a special tool for that. So now I need to cut a circular recess in here. I think it's just cosmetic. This is where the water goes. So I'm going to try and make a tool to do this. Well, the things you end up making. But hopefully this tool will work. Okay, so I've centred the piece in this 4-jaw chuck. I've centred using a gauge on the sides, and I've put a carriage stop here and a carriage stop at the other side, so I can basically just move the carriage between those two stops, and I can retract the cross slide by 1/10th out at a time. Now this is an interrupted cut, so it's got to be sort of very secure in this chuck, so hopefully it'll work. Seems working. Yeah, it seems to be working okay. So I'll carry on off camera and I'll get back to you. Well, that's looking pretty good. But one of the problems here is with the cutter face being here and drawing it back, every time I move it this way by 5 thou, it's more and more difficult to cut this far edge. It's impossible, because you're not cutting on this side, you're cutting on this side. So what I need to do now is just to reverse this cutter, so the cutting face is here, and then I think, having done that, I need to run the lathe in reverse and cut like that, pull it back 5 thou, go in again, pull it back by 5 thou, go in again. I just thought I'd show you this in reality. So I've switched the cutter around in the tool holder. I need to run the lathe in reverse like that, so it's cutting against this face here. I need to move the cross slide that way by 5 thou at a time, and I've set the carriage stop. You probably can't see it there. Oh yeah, you can. So I can't go beyond the bottom of where the water hopper is. So that's the idea. Well, that looks pretty good. I'm really happy with this tool that I made. Now I've got an admission to make here, because when I originally machined the internal bores, I was aiming for 1.233 on the inside, and let me see, 1.234 on this outside one, and I've just measured them again, and they both measure 1.2345, and when I machined them I could have sworn I got them spot on. So I don't know whether I've had a senior moment somewhere along the lines, but anyway, these are only 0.2 of a thou smaller than the actual cylinder sleeve, so I think I'm definitely going to have to use some JB Weld in here when I press the cylinder sleeve in, or in fact it might just drop in. Okay, so I've just put a very thin smear of JB Weld on the inside surfaces. Obviously I've cleaned everything up beforehand. And I've made this little plug here, so I can use that to press against. Okay, so I've put a couple of marks on here, and that's where this surface, the inside surface, will sort of meet. So when I get close to that, I'm going to put a bit more JB Weld round there, and then do a final press. Well, there's a bit of resistance, which is good. Blimey. Not even sure that we need any more JB Weld around here, but we'll put some on. Well, I gave it an extra press off camera, and boy did it need pressing in. That is really tight. So I'm glad that these inside faces aren't any smaller than what they were. Now on the inside at the far end you can see where it's pressed out some of the JB Weld, but I'm going to leave that because that'll act as an extra seal, and I mean hopefully the piston won't go that far up the bore. And I suppose the only sort of minor effect it might have is the compression ratio. But my feelings are, if I try and sort of get rid of that, I'm going to get some on the inside of the bore, and I'm going to make matters even worse. So I'll leave that to cure overnight. So now I need to cut a groove in the base for it to fit in these lugs. So before milling the slot, you need to make sure that the sleeve is parallel in the vise, and if it isn't, you just need to tap the vise to get it in the right position. So I'm happy with that. So that's the edge. Now find the centre. This is 6mm, so it needs to go 3mm. Zero the x-axis on the DRO. And then I need to move into the centre here, so that is 3/4 of an inch, and that's 1/4 of an inch, so it's 3/4 of an inch plus 1/8 of an inch. So we need to go down to a depth of 1/16 of an inch. Well, that seems to fit okay. I've not drilled and tapped any holes yet, I'll do that later. And I've drilled the hole for the inlet and exhaust port, that's where the carburettor will fit. And I've also centre drilled the position of where the oiler will go, but I'm not too sure which oiler I'm going to get at the moment, or whether I'm going to make my own. But so far so good. Well, I've just had an absolutely fantastic surprise. The postman's just arrived with a package from the United States of America, and in it are 3 back issues of the Strictly IC magazine, which feature the George Trimble method of making piston rings. And I can't thank Earl enough. Earl has bought these for me and posted them to me, and I really appreciate that. And there's also some other fantastic content in here as well, so I'm really looking forward to reading them. So thank you, Earl, I really do appreciate that. Now, in terms of this cylinder block, I must admit I'm not a fan of the design, because once this cylinder sleeve is pressed in there, there's no way you're going to get it out, whether or not you use JB Weld. And I believe Earl has followed the same sort of approach of putting a bit of JB Weld in there, just to make sure you get a good seal. And this looks like I have got a really good seal. And in terms of water, I've not put any water in it, but yeah, it feels to be really good pressure there. So anyway, I hope you found the video of interest, and I hope to see you later.